Okay, everyone, we're going to move on to lesson number 11, and we're going to deal with some new terms here that you probably haven't heard of before. The learning objectives are defining what a mole is and molar mass, and calculating molar mass. Look, this is going to be something brand new to all of you, but if you continue on with science, and specifically chemistry, you're going to be using the word mole so very much. It is a way of accounting, it's a way of doing calculations with chemistry, and really it's going to become just something you're going to use all the time. So we're going to do our best to move on. If you want to follow along, we're on page 107 of the textbook. I would ask that you have your periodic table with you at this point in time. Now, what is a mole? Mole is a unit of measurement used to quantify the number of things. Here's how I think of it. We all know that if I say to you, you have 1 dozen, that equals 12. Now, a dozen doesn't always mean eggs, but if I said you have a dozen eggs, well, you know you have 12 eggs. But I could say you have a dozen apples, well, then that means you have 12 apples. So the word dozen simply means 12 of something. Okay? Now, when we deal with chemicals, we are dealing with atoms. We are dealing with things that are so small. I mean, think about a basic reaction. And let's just say you took a little bit of a crystal powder or whatever, sorry I can't draw, and then what you did is you dumped it inside of water, or there's some chemical in here, and you add this into here. Well, think of all the little atoms that are inside of there. I mean, that's an incredible amount. We could never count. We wouldn't want to try to count that high. But the word, you're saying dozen, that's not enough. Like, think, we're going to have billions and trillions of little atoms floating around. So what we do is we use the word mole. 1 mole is equal to a huge number, 6.02 times 10 to the 23. Now that is essentially a number with a whole bunch of zeros that I am never going to try to draw out. It is going to take forever. Can you imagine counting that many particles? Anyway, my point to you is this. If I say you have 1 mole of atoms, you can say, well, I have 6.02 times 10 to the 23. That's how many you have. If I said you have 1 mole of apples, well, guess how many apples you have? You have 6.02 times 10 to the 23. My point is, the mole is not necessarily associated with chemistry. It's simply a way of quantifying an amount. If you say dozen, you mean 12. If you say mole, you mean 6.02 times 10 to the 23. Now, again, keep in mind why we're doing this. We're using this mole, this huge quantity, because when we're dealing with chemical reactions, there are just billions and trillions of atoms involved. And we have to have a way of accounting for all of them. 6.02 times 10 to the 23 is a fair enough way of doing so. Again, and if you want to read more about this, please look at page 107. In fact, they actually write out for you the entire 6.02 times 10 to the 23 number. If we move on to molar mass, we're now on page 108. What we're trying to consider here now is, let's imagine that you have 1 mole of something in your hand. Okay, so I'm going to use an example of methane. The formula for methane is CH4. I want you to picture that you're holding 1 mole of that in your hand. How many particles do you have? Well, you have 1 mole, so you should have 6.02 times 10 to the 23. But what if someone said to you, what is the mass of that 1 mole? So what that's called now, that's the molar mass. And here's how you have to break this down. You must know the formula. The formula for methane is CH4. If you look, you have carbon, we have 1 of those. Please look at your periodic table. The atomic molar mass of carbon is 12.01 grams per mole. I go times 1. Why is that? Well, because I only have one of them in the formula. So that's 12.01 grams per mole. Let's now look at hydrogen. The atomic molar mass of hydrogen is 1.01 grams per mole. How many of those do we have? Well, we have 4 of them. So I'm going to go 1.01 times 4 for a grand total of 4.04. To figure out the entire molar mass, we must add these two together, 16.05 grams per mole. Now, this is not a difficult calculation. You have to account for all of your elements. But my point to you is this. This is the work that you have to show. And you must include all of your units, just like I did. So your final answer has to be 16.05 grams per mole. All right, now let's try another example. Now, there is another way this might happen. In some cases, you simply are going to be given the formula. So here's a question. Find the molar mass of magnesium chloride. Well, you're going to need to figure out the formula. Here's magnesium, here's chloride, chlorine. How do they go together? That's MgCl2. You see, here's the problem, gang. You have to have the formula correct. Because when you go through this, magnesium is 24.31 grams per mole times 1. How many chlorines do we have? We have 2. That gives you a grand total of 95.21 grams per mole. But think about this. I put this up here on purpose. What if you made a mistake? What if for some reason you got MgCl4? Do you see how that would change your final answer? Now that's a real problem. Molar mass is an easy computation, it's an easy calculation, but you must have the correct formula. If you do not have the correct formula, you will never have a chance at getting the molar mass correct. Let's try another one. Find the molar, that's an O, molar mass of, let's say, aluminum, let's go hydroxide. Well, you're going to have to find a way to get there. So you look at aluminum. The charge of aluminum is 3+, and it is combining with hydroxide. Now, hydroxide is one of your polyatomic ions. Hydroxide is OH, 1-. So how does this come together? Well, balancing the charges is not a big deal. I hope you all see that we're going to need 3 of these. But remember what I said in a few lessons back. When you need more than one of the polyatomics, you must put a bracket around it and then put how many you need. That's the correct formula for aluminum hydroxide. Now, what does this give us? So we have aluminum. The atomic molar mass of aluminum is 26.98 grams per mole times 1, because we only have one of them. So that is 26.98, obviously. Now here is a trick, everybody. How many oxygens do you have? Well, here is the trick, and you've got to remember this. This 3 means that we have 3 of this entire group. We have 3 hydroxides. So 3 hydroxides looks like this. OH, OH, OH. Well, how many oxygens do I have? 1, 2, 3. I have 3 oxygens, so I go 16.00 grams per mole times 3, and that's going to give you, so the math now becomes simple. Hydrogen, well, how many hydrogens do you have? Again, not difficult math, but you have to understand what that 3 does. So the atomic molar mass is 1.01 grams per mole times 3. So we have, we're going to get a grand total here. Now remember, grams per mole. You've got to include your units at every step of the way, okay? So you're going to have 48 grams per mole there. This is going to be 3.03. If you give me a moment, I'll total this up. 0.98 plus 48 plus 3.03 to a grand total of 78.01 grams per mole. So again, what does this mean? Well, I have 1 mole of aluminum hydroxide in my hand. How many particles? Well, that's still the 6.02 times 10 to the 23. How much, what's the mass of 1 mole? This is the mass. It's 78.01 grams per 1 mole. The key point here, everybody, you must get your formula correct, and you must understand how this 3 affects a polyatomic ion. Heck, let's do another one just to make sure we're on point here. Let's do molar mass of cobalt 3 sulfate. Okay, so we have to be careful with these things now. So we have, remember, we have a multivalent ion. So cobalt 3 plus is being added to sulfate, which is SO4 2 minus. That's a polyatomic ion. They're going to come together, CaSO4, but we better do our charges here, balance things out. This is the lowest common denominator method. So times 2 times 3. So we need to have 3, I put an A there, that should be a CO. So we must have 2 cobalts and 3 SO4s. I hope you're thinking that doesn't look right, because we must have a bracket around there. Remember, we have more than 1 polyatomic. Now, how do we calculate the molar mass of this? Well, let's just be sure. So we have cobalt. Cobalt has an atomic molar mass number of 58.93 grams per mole. We have 2 of them. Okay, so 58.93 times 2 gives you 117.86 grams per mole. How many sulfurs do we have? Well, we have 3 SO4s. So SO4, SO4, SO4. I count 3. So we have to use a number there of 32.07 grams per mole times 3. And that gives us a value of 96.21 grams per mole. And finally, we have the issue there with the oxygens. Now, how many of those do we have? Well, if you look, I have 4 of them here. I have 4 of them here. And I have 4 of them here. In my opinion, we have 12. 16.00 grams per mole times 12. That's going to give you 192 grams per mole. If we add that all up, it's going to give us a pretty big number. Plus 96.21 plus, should be 406.07. Now, you might have noticed a quick cheat way here if you want. I'm trying to be very explicit, and it's hard over a recorded video when I'm not in front of you. But another way of doing this would be, well, this 3 goes right there. Now there's nothing, that's a 1, so we have 3 times 1, so that means you have 3 times an S for sulfur. And 3 times 4, that means you have 12 times oxygen, if that helped you guys out. Anyway, that's kind of maybe one of your more complicated examples. You can see again, If that formula isn't done right and you don't account for your numbers right, you're going to have some deep trouble with this one. Finally, let's look at a molecular one. Let's go find the molar mass of, let's go trinitrogen hexabromide. So again, you're going to have to remember your prefixes here. So this means we should have 3 nitrogens and we should have 6 bromides. And that, of course, is going to impact how we do this. So we're going to have nitrogen. So nitrogen is 14.01 grams per mole times 3. Okay, so that gives you 42.03 grams per mole. And the BR is going to be 79.90 grams per mole times 6. That's going to give you, wow, 479.40 grams per mole. Add that all together. Gives you a grand total of 521.43 grams per mole. I hope this is becoming a little more clear for you now. It really is all about having the right formula. If you don't have the right formula, there's no way of getting this right. So I'm going to give you guys some practice with that, and hopefully you will find some success.